This is part 2 on long division in Mind over Math. Again, we use the concept of DMSB, divide, multiply, subtract, bring down. And the purpose of that is to just help you remember what step comes next. So now we're going to continue this with part 2, and I want to remind you of the different ways to write division, of course, in a very simple problem. For instance, when you get a remainder of 1, you want to check it, you take the 4 times 3 and add 1, and that will give you the dividend. Remember, we went over the vocabulary of divisor, dividend, quotient, remainder. If the divisor has an x in it, like all of ours in this video will have, it's called d of x. If the quotient has an x in it, as all of them will in this section, you call that q of x, that's quotient. R may have a remainder, will have x's in it too, so that's r of x. And dividend, we would call that f of x. So that says when we check this, just like this simple problem above, the divisor times the quotient, d of x times q of x, plus the remainder with an x in it, is equal to the dividend. And that's what we're practicing here. So let's do DMSB. So in this problem, if we divide the lead terms, x cubed by x, we get x squared. And I like to put that above the 6x squared because that tells you when you get to the right margin, you're done. You don't have to keep dividing. A lot of times people will say, I lost where I was. But if you follow DMSB, then you'll be able to recall what the next step is. You won't get lost. So I multiply, that's the m. So the x squared times x is x cubed. The negative 3 times x squared is this. Then I subtract, so that made the first column is going to and must always add to 0. But the second column is negative 3x squared. And then we go to B, that's bring down, so I bring down this x. And now I start over again. I divide lead term, now the new lead term is negative 3x squared, over the lead term of the divisor. Notice I'm not using the 3 here until I multiply. And I get negative 3x. And now I'm ready to multiply. So now I get negative x squared plus 9x. Then I'm subtracting. So I have to change both signs. Once again, notice this first term adds out to 0. It always has to add to 0 or you are on the wrong track. You're missing something. One more time, we get negative 10x plus 30. And we divide the lead terms again and get negative 10. And of course, there it goes up in the quotient. Now notice I take the negative 10 times this. I don't take these other ones times it. I'm done with those. I only am concerned with negative 10. When I multiply that, I get negative 10x plus 30. I subtract, so that means I change both signs. And the good news is I get a remainder of 0. So this tells me that x minus 3 is a factor of this polynomial, x cubed polynomial. Now let's keep looking at that. Now notice that I took the 2 quotient and the divisor and wrote them side by side. And the reason I'm doing that is because there's a chance that this x squared minus 3x minus 10x will factor And it does. It factors into x minus 5, x plus 2. So an x cubed right here tells me I should be able to get 3 solutions. Now, are they always going to be really nice remainders of zeros and work out that way? Well, no, they're not. That's actually the next problem. But I do want to write these as factors. So that's that row with equals 0. Set each term, each factor equal to 0, which is called the zero product property. This last section here in the red, those are actually called zeros, solutions, we might say solve, x-intercepts, and actually this whole system, long division, can be used to be factoring, to be a method of factoring, especially when I set them equal to 0. So I'm going to do this problem again, but I'm going to make one change here, and I'm going to change this last term into 32. And I'm not going to go through this slowly, but I do want to divide lead terms again and write them above the x squared above the negative 6. Multiply, subtract, DMSB. Negative 3x minus x. Divide the lead terms again. Put the solution up in the quotient. And again, I'm not using this x squared now. I'm just taking negative 3x times x times negative 3. And that gives me negative 3x squared plus 9x. What do I do next then? I subtract. So I subtract, change these 2 signs right here. This adds to 0 and always will, just like this did. And now I bring down. So I divide one more time and get negative 10. Now this looks just like the last problem. And when I multiply, well, what happens? I actually get a remainder. And so how do I write that? Well, let's simplify this a little bit. First thing I do is I take that 2 and I write it over the divisor. So I put a plus 2 because this is plus 2 over x minus 3, which is the divisor. But here's what's great. There's actually a second alternative here. Next thing I can do is I can use this 2 as a point on the graph. You go, well, how does that work? Well, you'll notice over here, I took the x minus 3 and x equals 3. So this 3 is actually going to go with this 2. This is the x and this is the y. So this is actually a point on this graph. Now, is it the x-intercept like the last time? Well, no, it's not. But that's all right. All we wanted to do was to show that you can do long division and you will get remainders. Well, let's look at the graph. This is it, x cubed minus 6x squared minus x plus 32. Now this is on Desmos. This is a really great way to do graphing. This is free and it's online. I love Desmos and use it a lot. Highly recommend it. But here's the graph right here. Maybe you want to notice this. This 32 is actually right there. That's the y-intercept. And 3, 2, that's the remainder 2. 3, 2 is a point on the graph. So it's not just a waste of time when I have something like this happen. A remainder is actually going to give me a point on the line. So let's go back. Where is that point? Well, is this number set equal to 0 or 3? That's the x. And the remainder is the y. And this is actually a point on the graph. There is no wasted motion with this type of math. Thanks for checking out our many videos on trig, geometry, and algebra. Subscribe down below, give us a thumbs up, comments on topics you want.